So I've been working with time series data without being explicit of it being time series. And recently I started actually like doing more and more machine learning tasks with time series. So I wanted to kind of decide for myself, understand for myself what are the different tasks, what are the problems people trying to solve with for time series, and what frameworks in Python I can readily use. So this would be overview of that. Great. So quickly, I'm a former physicist. I'm now working in
Hello.
so right now I'm looking to do so in my current task I'm trying to do time series classification and clustering tasks. So to do that I want to pick up good methods and frameworks so I don't have to code everything or like use code directly from papers. Um, there are several frameworks that have been developed in the last 2 years that combined traditional time series methods and state-of-the-art deep learning methods that are being developed. And they provide easy interfaces and pipelining. And pipelining, like I'll address it maybe a little bit more, but um, the framework I want to use uses pipelining from sklearn, where you can effectively chain estimators together and train them together. So you can um, kind of describe all your machine learning tasks together and optimize them together on a given data. And
Yuri,
okay. Um, yeah. So, and the other task, like a goal for what I'm trying to do is to understand when to use time series methods and when not to use them. Because I think if you've seen from the previous talks, in a lot of cases, um, you want to use like a pure machine learning method like XGBoost, and it actually gives you very good performance, sometimes better performance. For a lot of other tasks, people use various deep learning methods, like using LSTM to extract information from time series from the sequence, using one-dimensional CNN again to extract features, and then through the sequence. Or recently, there have been a lot of transformer-based methods in time series, both spatial and time series. So I kind of want to define like when to use which method. Um, so what tasks are solved with time series? Most famous is and most used is forecasting. So given several values, try to predict what would be value at the next step, second step, and so on. And you can predict few steps in advance, so you can predict once and kind of move your time series and start using your own prediction. Um, our interesting variation of task with a time series is single value or multivariate time series, and also how much other information you know about the system. And the other information is called uh, exogenous variables. Sometimes in some systems it's called covariates. Um, so one task that works well and actually work with forecasting for it is doing an imputation, especially if you want to run some other algorithm and your data is missing, but you need to run it today. How do you predict the value that you want to use in actually like doing your uh, high quality other high quality algorithms? So forecasting works really well for imputation. Um, the other very specific task on time series is annotation, meaning find specific patterns in time series. Maximum value, minimum value, uh, combination of the same points. So I used it in agriculture in trying to find features of NDVI curve. NDVI curve is um, is a combination of bands of satellite data that basically show you greenness. So it's a combination of red and infrared, and like a red band is being absorbed by plants. So effectively, like how green the plant is can kind of gives you that combination of bands give you really good feeling how green your your vegetation is. Another task that I worked on before is time series regression. Um, it's you can kind of just you can define what it is, starting from forecasting. In forecasting, you predict time series. Your predictive your dependent variable is time series. For regression, it's a value. So essentially, you can think of it as having machine learning tasks where your variables are where your dependent variables are time series. And typical task in agriculture is prediction of the every year's yield, which you have time series data from your weather and again your NDVI, whatever your satellite data gives you, and you want to estimate how much corn or soy or any other uh, product it will be produced. Classification, the task I'm going to look at before is obviously like having various data and trying to find which class new time series belongs to. Very similar task, but done with a lot less labeled data or with no labeled data is clustering time series based on some features. And specifically for time series, it's very important to define good distance between time series, which picture below shows a dynamic type warping distance, which you can see kind of lets your time series adjust a little bit so you compare points that are similar. So you kind of assume that you don't compare points at the same time, but you try to compare more similar points around the same time. And yeah, the task that I haven't worked on but is important for time series is anomaly detection. So if you have set of time series, what should you expect and what's an anomaly? So why time series algorithms are different? I think people have been working with time series always. That's very important. It's very important data. Traditionally, algorithms were developed differently in different fields. One of the big areas with time series, working with time series is learning EKG and trying to understand like what's going with the patient based on the cardiogram data. So a lot of methods were developed there. In kinematics, a lot of methods were developed to study motion. In economics, they developed different types of methods. So there are a lot of very specific methods for time series. You can solve them with normal machine learning methods, but you need to be careful when you do this because you want to avoid data leakage. You want to always split your train and test data. So you always test on the future data, so you never like learn the future in your algorithms. And there are other kind of things you need to watch out for. So as I said, the time series was studied for a long time. There are a lot of traditional methods for time series, like a Riemann or exponential smoothing, and a lot of other methods not for prediction, not for forecasting. And recently, there are a lot of methods done with deep learning that are specific for time series. So kind of what I wanted to do, I wanted to get a tool that will give me all the packages so I don't have to kind of decide what method to implement or what method to try to, bring into my code base. And yeah, so that's why I'm looking for the framework. So I want to quickly describe like 4 frameworks that I really like for various reasons. SKTime is a framework. They're all open source, all available to use, but that are built for slightly different goals. So I'm going to talk more about SKTime. It's a framework most closely resembling sklearn, and integrates with it the most. They do a lot of non-forecasting, so that's why I'm kind of picking it. But they also have good forecasting methods, both traditional and deep learning. Dart's framework is very strong. Is very strong for forecasting. Also has an interface very similar to sklearn with like fit predict, with a little bit more variations. They've been implementing every deep learning method that's been published in the last 2 years, so it has a very good like predictive methods. It also has a good framework to work with time series. So when I worked with it, a lot of my data was missing, so it has a lot of imputation methods that you can pick defaults, so you can pick different variations. So it's a very strong. If you need to do forecasting, that's probably the strongest framework to use. There's a really interesting framework called Nixla. It's built for kind of large throughput, so you can do like an Amazon scale predictions with it. They also implement a lot of prediction methods, but they also actually kind of do their own improvements. So they're more of a data scientists than software engineers. So there's a very good deep learning prediction method called NBEAT, which was developed recently. So they kind of build their own hierarchical version of that on top of that. And then there's a very interesting framework built in Australian University, I think University of Monarch. It's the it's a method. It's a framework that has like builds 10,000 features. I think they originally developed it from EKG data and a lot of other like very specialized methods, and they just like build a lot of feature generation methods. So you can throw all of them in and like see what helps. But again, it's in MATLAB, so not ready for production. But what you'll see is that actually people take feature generation methods from there and create production level, like much smaller production level features. So, and then you don't have to do a framework. You don't have to use specifically machine learning time series framework, and you can try to use XGBoost or other machine learning methods directly. And there are 2 ways sort of doing it. I think I'm going to talk about it later as well. But you can think of it doing of like addressing time series and putting it into tabular format in 2 ways. One is you can treat each time update as its own feature. And it actually works well for agriculture for yield models. So every week we do an observation. We only have about 25 weeks worth of data. So you can just say, you have like 25 features, and you use all of them in your tabular method. Or what you can do is you can generate your own features and essentially remove time series, but run feature generation methods. And one very popular framework that's doing it is called TS Fresh. And or you can actually generate features that you know from your domain. So in like a kinematic motion data that I'm working now, I know velocities, accelerations, radius turns are important, so I'm generating those. And here there was a really interesting lecture and YouTube lecture, but also a course on feature engineering for time series. So I put it here as a reference. So yeah, so I chose to use SKTime because it's has a lot of methods for classification and clustering. It's compatible with sklearn, so you can actually start with SKTime and then decide not to use time series specific methods, but still use the whole infrastructure for doing data split and calculating of the accuracy. And you can use pipeline from sklearn, so you can actually combine multiple methods. But it also has good support for regression and forecast. If I'll learn this tool, I can do other tasks as well. And they're very responsive. They're actually actively developing. So far, I'm really happy. So the task I'm trying to do is time series classification. So this slide is those pictures are borrowed from SKTime presentations. What they do is they so your typical task is you have classes of time series, and you want to build an algorithm that given the next a new time series, you want to assign it to the class. So interesting way of looking at this is to look at the problems that are you can look at it as just sequences. Like time is just an abstract kind of so we most of the time we do have timestamps, and we actually have observations that are or data that came at different times. But you can think of time series as just being a sequence of data. So this is an example where you can do image classification and convert it into time series method. So if you have like a skull, or you have a spear of the arrow, what you can do is you can trace the outline of your object, going like doing like a radial outline, and then instead of a picture, you now have a sequence, so you can use time series method on it. So I think I already addressed some of this. So there are like ways to go from time series to tabular data. They call it tabularize, where each update is separate. You can actually replace time series with specific features that can be generic. TSRS is really good tool to do that, to generate a lot of features, and it does like max min, any sort of I think derivatives. They do Fourier transforms. Yeah. The other way of doing kind of removing time series from this problem that I've used before is actually it works for multi-series time series. Is you can think of it as removing time component at all. Think about it this way. Let's say you have a trajectory with a position and data. If you now have this data, but you remove timestamps, so now you have just collection of points. So it's a point distribution. If you look at it yourself and look at it, let's say graph for, you can see points in, let's say position and velocity space, you'll still know what it is, right? You know something is moving. You don't know which direction it's moving, but you know trajectory. So it actually removes very little information, but now it's no longer a time series problem. And again, so that's removing time series, but you can use specific time series classifiers. And I listed uh, three very powerful classifiers um, that people have been developing for time series. So Rocket has been developed recently. Um, I think it's a combination. What they do is they sort of do classification of different time intervals. This next one, the HT2, is more ensemble of other classifiers, and dynamic type warping is based on like this good distance for time series, which kind of adjusts them a little bit. So the problem I'm trying to solve right now is motion classification. So good examples of that would be gait classification. You can actually distinguish between people based on the information from their gait. How, if you record how people walk, you can actually identify them very well. Or like the other uh, program from real life is you see something in the air, and how do you know if it's a missile, it's a drone, or it's air balloon, right? So it has different trajectories. Um, so um, so traditionally, people don't use time series methods. Instead, they generate features, physics-based position, velocity, rate of turn, um, maximum, minimum velocity. Uh, but I'm trying to see if that can be done using sort of generic time series feature generation. So here I learned a lot of resources I looked at when kind of learning about time series. Data Skeptic is a really good machine learning podcast, and about a year ago he did a whole season on different time series problems. SKTime, besides having good presentation of their own product, they actually list a lot of other related software that's addressing different time series problems. For forecasting, the standard for like a golden like data set for forecasting is coming from this M competitions, M3, M4, M5. I think they might have them. They might doing M6 now. So it's typically sales data. I think at least the last one was a sales data prediction. And the other good place specifically for classification to get the data to try to like compare different methods is website called Time Series Classification Repository. So they have motion data set and they have a lot of like other classification methods. So one interesting method that was used recently is trying to use transformers on time series data, and it's still unclear whether, and it looks like maybe transformers is not the best technology to do for forecasting, but they work fairly well for classification and regression. But that's just a kind of beginning, people just starting to use them. Again, because a lot of still time series problems don't have a lot of data, and with transformers, yeah, you do need a lot of data. But if you have weather and climate information at the global scale, that's where they starting to use those methods well. So quickly in conclusions, I listed good frameworks that you can start with if you have time series specific tasks. They all come with a lot of methods implemented, and yeah, hopefully they'll start implementing transformers as well, so I don't need to, read more papers. All right, that's it.
But you have two more slides, right?
Oh, this is a backup. It's more, yeah. So this is more how I want to extract my specific data. Um, I think some of it actually already went into the other presentation. Oh, yeah. So I worked on distances. I worked on distance problem before, and there's examples of distances that can be done in time series. I used a Fréchet distance, which is really good distance for both time series and point distributions. It's also called Earth mover distance. It's really tells you how close distributions are to each other if you were to transform from one to another. The dynamic time warping is a good measure. Again, if you think like time series is stretched a little bit, so it's not perfectly aligned. And the other interesting methods I've used that gives you very similar result, but sort of without sort of completely. It's a very similar actually. Like if you look at the algorithms, in math it comes out to be very similar, but it like philosophically it's completely different approach. You build your hidden Markov models on your various classes of time series and you train them, so you learn representation states of different classes, and then you see if your new time series you take two time series, you learned representations, and you try to see if the one time series applied into this matches well this hidden Markov model, right? So what you do is um, you run your Markov model on the time series, and like if it matches, like it will you'll have like a good fit to it, so your error will be really small, and then yeah then you match the right class. So that's sort of interesting way of doing distances without time series specific methods. All right, and I think that's it.
Okay. Good.
Again, I apologize for delay.
Well, come on, it's not your fault. The airline was delayed, right? And so, anybody have any questions? Oh,
What is the application aspect of it's like analyzing how, let's say, stock behaving, or what any other cases where we can apply it?
So I think like for forecasting, people try to do it with stocks, but I don't think the generic methods work very well. For classification, I don't know if classification is applied to stocks that much. Typically, for classification, you want to the problem I'm trying to solve is you see an unknown object, and you want to know what it is, but you already observed a lot of other objects flying around, so you want to have like this good model that you can quickly look at important features and say what it is. Then um, like more motion gate detection is another good problem. Like you can actually recognize people. Like you can see who's walking around. Like you can like those are useful in security applications. You can actually based on classification of time series, you can tell who's walking around like 100 meters away. Yeah, so those like two questions, like two problems I have in mind. In agriculture, we do time series classification on. Yeah, I think I might get disconnected really soon because my computer is almost out of juice. But in agriculture, we're trying to recognize where people planted corn or soy, because they have very similar remote sensing data, but slightly different. And that slight difference is enough to do classification.
Thank you.
Mhm.